Lesson 6-1, Operations on Functions. So in this section, we are going to be talking about adding, subtracting, multiplying, dividing, or composing functions together. And as we complete these operations, we are going to need to state any restrictions on the domain from all the original functions and our simplified answers. So to start with, we're going to talk about what I mean when I say restriction. So a restriction is when the domain is not all real numbers. And we're going to state what the domain is, again, for all the original equations and our simplified answer, or we're going to state what it can't be. So it depends on if we have a countable number of elements that can't be in the domain. That's when we would say what it can't be. And if we don't have a countable number, so infinitely many, then we would state what the domain is. So we're just going to go over different examples and talk about how we would write each type of situation. Okay. And I'm going to add a little note here. So again, when we are talking about the restriction, we are stating what the domain is, or we are finding all the values that are not in the domain. Now, when we're talking about the domain, remember we are referring to all of the x values. So when we look at that first example, this represents a linear equation. So if we're thinking about our graph, it's going to make that line. And on all linear functions, we don't ever skip any of our x values and is continuing to go to the right forever and to the left forever. So in this case, if we're talking about a restriction, we would say that there is none. Or if we were going to write it as the domain, we would say that the domain is from negative infinity to positive infinity, or we can use that phrase all reals. So it's important to pay attention to the question and how the question is phrased to know which way you would answer this. So if it's saying to state the restriction, then we would say none. If it's asking us for the domain, then we would write it like this. Or when you're working on your ALEKS topics, it'll be very clear if it wants you to select the none option or to write it in this format. So again, just make sure that we're paying attention to those little details and reading those directions carefully. Okay. Now on our next example, I have that squared. So this is my quadratic equation. So that makes the U shape. So as our U goes up forever, it's also going to the right and to the left forever. So again, just like our linear equation, there is no restriction on our possible x values for our quadratic equations. Or again, we would write it as negative infinity to positive infinity, or use that phrase all reals. Now in our next one, we haven't talked about what these graphs look like yet, but I do have a variable in the denominator. So it's not going to look like anything that we've seen so far. So what we need to do is think about it in terms of a fraction. So when we think about fractions, what number aren't we allowed to divide by? And our answer to that should be 0. So that means if I can substitute something in for the x, where the denominator simplifies to 0, that value can't be included in our domain because it doesn't make this simplify to a true statement. So if I were to think of this as equal to 0, and then I solve it for x, I would add that 5 over. So I would say that x equals 5. So that means then if I substitute 5 into this and simplify, I get 0, which is not allowed. So the restriction for this, we would say that x can't equal, so I'm going to put a little slash through the equal sign to show the can't equal part, 5. So this would be my restriction for this type of problem. Okay. So same thing on my next one, I have that fraction. So if I can substitute something or more than one thing in for x to make it simplify to be 0, whatever those number or numbers are, that has to be the restriction. So again, I'm thinking of this as equal to 0. And then because we have a quadratic equation for this, that means I need to try and factor it. So I need two numbers that multiply to be -6 and then add to be -1. So I would want to choose -3 and +2. Okay. So again, if I solve that, so still thinking of it as equal to 0, I would have x equals +3 and -2. So again, that means if I substitute 3 into the x for both x's, and then I go back and I substitute -2 in for both x's, and I simplify, I'm going to get zeros for my simplification, which isn't allowed in the bottom of that fraction. So I just need to make sure that I'm putting my slash, that equal sign, to show that I can't have 3 or -2 in my domain. And this is exactly how we would write the domain. Okay. Now, most of the time when we have a fraction, we should be able to find a number or numbers that our x can't be, but that doesn't always happen. So as I look at my next example, again, thinking of this as equal to 0, so I would have to subtract the 5 and then take the square root of both sides. So in this case, because I have the negative underneath the square root symbol, I would end up with an imaginary number. Now, we can't graph those on our real plane. So when this situation happens, that means that I can't find a number, a real number, to substitute into the x where this would simplify to be 0. So this would be an example of having a fraction where we don't have any restrictions. So my restriction for this one would be none for the domain. Or again, we would write it as that -infinity to +infinity. Now with our square roots, we have to think of numbers that I can actually take the square root of without getting that imaginary number. So that means that this, in this case, has to be a positive number. And I know that because if I have a negative here, just like on this previous example, I get that imaginary number. So the smallest number that we can take the square root of and still get a real number is 0. And then I would need everything bigger than that. So my restriction, the way I would write this, so that domain has to be from 0, and I would use a bracket because I'm including that number, to +infinity. Or I could write it as x is greater than or equal to 0. So these statements mean the same thing. So you're writing it as one or the other. You do not need to write it as both. Okay. So then on my next example, the idea is going to be similar. So I'm going to figure out the smallest number that I can substitute in for x, and then figure out if I need numbers that are bigger or smaller than it to keep whatever's inside positive when I simplify. So the way that we can approach that is similar to a fraction, where I take whatever's on the inside, and I'm going to set it equal to 0 and solve it. So this would give me -3. But unlike our fraction, I'm not going to just put a slash through my equal sign. So now I have to decide if I want numbers bigger than -3 to make this a true statement, or numbers smaller than -3 to make it a true statement. So if you're not sure, you're just going to pick one. So I'm going to pick a number bigger than -3. So if I pick -2, -2 plus 3 is 1, and I can take the square root of that. So that tells me that my domain for this would have to be -3 to +infinity. Or again, I would write it as an inequality where we would say that x is greater than or equal to -3. Okay. So again, same thing on this next one. I'm going to take whatever's inside, set it equal to 0, and then solve it, and then figure out if I want numbers bigger or smaller than that. So I would need to subtract the 3 over, and then I would divide by -1, so I'm going to have a +3 in this case. And then now I'm deciding, do I want all the numbers bigger than 3 or smaller than 3? So again, I'm just going to pick one and test it. So if I pick a bigger one, so let's say I pick 4, -4 plus 3 is -1, and I can't take the square root of that. So I picked the wrong side. So just to verify, I'm going to pick a smaller number next. So I'm going to pick 2. So when I substitute it in, this will become a -2. -2 plus 3 is a +1, which I can take the square root of. So that means for my restriction, I would need everything from negative infinity up to 3. Or we would say that x has to be less than or equal to 3. So as we are looking at these, when we're talking about our restrictions, if we have fractions like this, we should have x can't equal to something. Or if it looks like this, we're going to have a none. And then anytime we're dealing with square roots, we're going to have a range of numbers for our domain. So again, to figure that out, we're just setting whatever's underneath equal to 0, solving it for x, and then deciding if we need numbers that are bigger than this or if we need numbers that are smaller than this. So what I would like you guys to do next is go ahead and pause the video and then write the restrictions for each of these problems. Now, as you're looking at these answers, I'm writing them in different forms. So if you matched one of the forms that I'm writing, that's fine. You don't need to include both. So sometimes it's easier to do the inequality notation. Sometimes it's better to do the interval notation. And some of that's personal preference too. All right, so again, make sure you are checking your answers. I am going to go back to number 6 in case you're confused by that one. So remember for this, I'm setting that denominator equal to 0. And then we would solve, so I would need to add that 3 over. And then I'm taking the square root of both sides. So since I have a positive number in here, that's why I have the restriction. Whereas on this one, if I'm thinking of that as equal to 0 and I start solving, I have that x squared equals a negative number. So when I take the square root, I have the imaginary one. So anytime this situation happens, that means I can't find a number to substitute in for x, where the denominator would simplify to be 0. But on this one, if I substitute in the square root of 3 for the x, and then I square it, that becomes a 3, and then 3 minus 3 is 0. So that's not allowed. And remember, anytime we are solving and we write in that square root symbol, we have to remember to include that plus minus. So you do need to remember both of those. And that's also because when I substitute in, we have to think of it as a parenthesis. So that negative is inside of the parenthesis when I square it. So this is still going to become a positive 3. Same thing with that other one. That gives me that positive 3. And then 3 minus 3 is 0. Okay. All right, so next we are going to talk about our different function operations. And we will do that in the next video.